Hello, this is the Artifact Review 1 for Project 28, Team 28, Proximity Sensing in a Post-COVID World. So our sprint goals this time around for Sprint 0 were just trying to get our environment set up and really just gain a better understanding of our project domain. So just a lot of research. I think a lot of us, most of us, I think all of us actually have no real experience other than what we've gained at ASU thus far in embedded programming and this very hardware-intensive project. So we did a lot of research. We were trying to gain understanding of, first of all, Atmel Studio, which is the tool that Microchip Technology provided us. It's publicly downloadable. It's accessible to everyone out there. But that's really how you interact and code and debug the hardware that they've provided us. We were looking at how do we export the data from this hardware, and how do we serialize it and deserialize that data, and how do we get it into usable data structures in a higher level programming language, where the next step really is to get it into the TensorFlow framework, where you're talking about machine learning. And so that kind of segues into the next research topic is TensorFlow, and what is that, and how do we use that in our project, and how do we analyze this data, and how do we learn from the data. We've also, and I think this will be an ongoing sprint goal, is to come to team understandings and agreements and solidify our processes and change things if they're not working and discuss those things in retro. I mean, that's always an ongoing sprint goal, but definitely a Sprint 0 goal. So if we jump into the repo here, so the GitHub project that we have, you can see the folder AVR128-RAWBLINK, as well as these two folders that start with Qt7. They correspond to these ATSLN files, and essentially what that is that opens that project in Atmel Studio. And if you actually go into one of these folders, you can see it's full of C files and H files and subfolders and packages, and we didn't actually develop any of that. There's a tool called Atmel Start, which we're going to be doing more research on that as well. It's very useful. It's designed essentially, it's kind of like a template generator, if you will. You essentially tell it what hardware you're working with, and it's very configurable, almost like to an electrical engineering level. But it essentially generates the project for you in that regard. So I think a lot of our coding is going to be outside of C, but it's definitely there. It's definitely present in our project. The git ignore file is self-explanatory. That's just to ignore files we don't quote-unquote garbage that we don't need, or local stuff that we don't need in our repo. The quality policy, this was part of that team understanding of processes and stuff. This is a quality process that we have currently. It's a living document, and we have checklists, white box, black box testing, our code review checklists for the reviewer and the developer. So we have that. Also, the general README file really just captures very high-level information. It's almost just like a landing splash page, if you will, on GitHub. But then if you go into the documentation folder, and we have one open pull request. I'm going to switch to that branch because it includes everything I've already shown you, and then a couple things that one extra folder and some other stuff in the documentation that will be included in Sprint 0 by the time we end the sprint tomorrow. So in the documentation folder, so you can see we did some work around Atmel Studio as far as the how to set it up and configure it, and just really high-level basic usage of it, like Hello World type stuff. You can see there's a screenshot of the hardware that we were provided, and it's just kind of a quick, this is how it's assembled. And this is a real basic Hello World where you start getting blinking lights on the LED. So that was kind of what we walked through on our sponsor. We just kind of wanted that documented, just in case for any reason you need to set Atmel up all over again. Here's some research artifacts that we had from exporting that data. There's a data visualizer in Atmel Studio, and how do we get that data out of Atmel? So that's kind of where we started that process of trying to understand how to get that data out. And then the next file is how do we get the data in? So how do we get it into some Python data structures? After some research, the team discovered that Python looked to be the best language to use, especially with TensorFlow. So how do we get that data out out of, and then how do we get it into Python data structures. And one tool that we've found as definitely a possibility to use is what's called Anaconda, and here's just a quick screenshot of the landing page. It's basically a toolkit that includes a Python IDE called Spider, which actually stands for Scientific Python Development Environment. I mean, this tool is basically for data science. I think it's a lot, but I think it's going to definitely do what we need it to do and what we're trying to accomplish in this project. And it works well. It works well with TensorFlow. It's easy to configure with TensorFlow, and then you're ready to code. So. And actually, if you see this last folder that I was talking about, the Python Qt7, this is basically like our first project that was created in that Spider IDE within the Anaconda toolkit. And we just have a couple of kind of like hello world level files, like can you run me? And essentially, it's a check to see if you're able to import TensorFlow. So basically you're checking is the environment configured correctly, and are you able to run a really basic program. There's still a lot of work to be done around TensorFlow and really understanding what it is, how it works, and how to code with it. We also have some artifacts on Google Drive. This is pretty much where we're housing all of our, I don't want to say non-technical, but all of our items that are more like deliverables for Canvas type stuff. So we have any videos that we've created in here that may or may not even be a deliverable. That it's kind of, you can't push videos to GitHub. So and then we have our sprints divided out. So you can see in sprint 0, so we have stand-up minutes and a retro board and our project plan review meeting minutes, things like that that are applicable for that sprint in an organized manner here with folders. We have our sponsor documentation that has been sent to us directly from our sponsor to kind of keep that together. And then our project plan template, software architecture, other things like that. So that's where our current artifacts look like, and looking forward to our next Sprint 1 to continue that research and to continue developing our tool set for how we're going to accomplish this project. Thank you.